Let's see. Okay, can people basically hear me? You can hit a little thumbs up there or a yes
Yep.
or whatever if that's the case. Um, hopefully everybody's doing all right out there. It's been a little, I've gotten a little bit into a groove. Hopefully the same is true for you. So, so I mentioned that I'm going to go to Zoom as kind of the video recording medium. And I don't know, I think the quality of the videos is probably significantly higher. Would you guys kind of agree with that for the most part, I guess?
Yeah, I'd agree with that.
It looked pretty
Okay. Yeah. I mean, I feel like I can do a lot more with it too. Like I can easily go back and forth between the board and do other things. I think just using the video tool that's native to what was in Canvas, that thing was pretty clunky, so I decided to scrap it. This seems to work okay. So that being said, what questions do you have? Any questions? Any questions? Anything at all? By the way, just to let you know, once we kind of get out of this session, I'm working on putting a quiz up. I think I'm going to have you turn that in by Friday. That makes sense. Okay. Is that what I said in the lecture? I was trying to remember.
Yeah, I think so.
Yeah, that's what you said in the lecture.
Okay. Yeah. So I'll give you basically a little bit more than a 24-hour turnaround on that one. And it will just be some aspect of anything up through independence, basically. So, and I only have one other thing I really want to talk about briefly on probability fundamentals before I move completely out of the Rosen text and go into that other one. I'll make sure that you have some kind of link where I think there's a link in the syllabus where you can get to the open source textbook I'm going to use for the stats part of the course. But I'll just make sure that's obvious on several fronts. You can click on that. You can get the book. You can download it as a PDF. I may even just upload the thing as a PDF. I have it and it's free. I don't think I would be violating any copyright or something. So I may just kind of put that up into Canvas itself so you can download it directly if you would prefer that. And everything from that point on will be out of that open source textbook. Problems, all the material will be in there. Okay. So any questions? I'd like you guys to be able to ask questions if you have them. I'm all ears. Where's Aiden when we need him? I don't think Aiden's in here. So do you feel like the the video, the way I'm doing it's working okay? Like having the videos, kind of coming in here and getting questions answered. I mean, again, it may be that this time just ends up being fairly brief most of the time, and I'm fine with that. I just want you to have the option of getting your questions answered as they arise. So,
We have a question in the chat.
ooh, that's a great question. Yes, thank you, Ryan. Yeah, I have an awesome example. So I'll do that. Okay, so let's do that. Let me get out of here. Am I still on screen here?
Yep.
Yeah, you're good.
Now, let me just ask you guys, is that fairly, am I like pretty big right now? Does that look big to you? Okay, because I mean, all I see is like a teensy, I just see a teensy screen of myself, and I see a giant screen of Adam Marvin. So
You can like pin someone's video so you can like make their.
what's that? Say again?
You can pin someone's video to make them the biggest one if you want.
Okay.
You like right click on their video and you say pin video.
Oh man,
It's the 3 dots at the top.
sweet. All right, so this is basically what you guys are seeing then if I do that. I want to minimize this thing over on the right also. How do I get rid of that over here? Sorry guys, how do I completely close this down?
What are you trying to close?
Oh, I'm trying to close the participant list just so I can see.
Maybe just click participants again. Yeah.
There we go. Okay. All right. That way I can see what you're seeing better. No. Yes. Okay, there we go. Okay. So here's an example. So suppose that you're drawing a card out of a deck of cards, okay? And suppose you say, well, I'm going to draw one card, and I want to pay attention to the percentage of time that I get a heart, okay? So we draw a random card. Okay, yeah. And then we say, all right, H is the event, get a heart. Okay. Then what is the probability of H?
0.25.
Yeah. So, I mean, there's 13 hearts over a total of 52 cards, which is a fourth. Yeah? Okay. Let's let R be the event. Okay, so there are some cards that are called like the royal court of the cards. That would be like Jack, Queen, King, and Ace. Okay, so it would be like the face cards and the ace. That would be the royal court. Okay? So get a royal. Get a royal. Okay? So R is the event, get a royal. All right, so what's the probability of R? How many royals are there?
16.
Yeah, there's 16. Okay, which if you reduce top and bottom by 4, okay, 4 goes into both top and bottom. Isn't that just 4/13? Okay, 4/13. Okay, so here's the deal. Okay, the sample space, here, I'm actually going to draw, I'll draw a picture of the sample space up here on the left. Okay, the sample space, in this case, looks like this. So here's the sample space. The sample space is divided up into 4 parts. One of the parts corresponds to, hearts, 1 to diamonds, 1 to clubs, and 1 to spades. Okay? And that's why the probability of hearts is a 4th, right? These literally are 1/4 size blocks here. But also inside of each one of these, you have the royal courts. You have the royal courts. Okay, so for instance, you would have, Jack, Queen, King, Ace up here. So this is Jack through Ace, Jack through Ace, Jack through Ace, Jack through Ace. And of course, down here you would have 2 through 10, yes? 2 through 10, 2 through 10, 2 through 10, 2 through 10. So the sample space is divided perfectly into 4 chunks. And then we've kind of, we've subdivided each of those 4 chunks into the royal court and then the other cards. Does that make sense so far, hopefully? Okay, so why am I doing that? Well, if you know, so let's compute the probability of getting a royal given that somebody tells you it's a heart. What is that? So if somebody tells you that you got a heart, that means that the sample space is no longer everything. Which part of the sample space am I in, for sure?
The top left quadrant.
I'm in the top left corner. Okay. Okay, so that's H right there. Yeah. So let me ask you, what's the probability of getting a royal given, and by the way, let me just point this out. That deeply affected the royals, didn't it? Before, these royals were possible, but also these royals and these royals and these royals were possible. Yes? But now somebody told me that you got a heart, and that eliminated a whole bunch of royals, didn't it? So there was a deep impact that happened when someone told me it's a heart. It eliminated a whole bunch of royals from our consideration. So there's clearly an impact happening, yeah? And yet, what is the probability?
4/13.
Yeah.
It's still 4/13. Which is just, it's the same as the probability of a royal. So did the probability change? Did the extra information that somebody gave us, namely that it's a heart, did that change the odds that I was going to get a royal? No, it didn't. But did that information affect the royals that I could actually get? Yes. It eliminated the spades, the clubs, and the diamonds from our consideration. But the odds didn't change. So do you see that? So what does that mean about R and H, though? Since the probability did not change, what does that tell you about R and H?
They're independent.
Yeah, R and H are independent. That's amazing. Okay, and that's because of that. We could have done a slightly different one. Like, what's the probability of H given R? Okay, so now somebody tells me. Okay, so now this is a little weird, but I have the royals are these and these. Okay, so those things are the royals. Yeah. Okay, those things are all the royals. Well, the royals consist of this top and this row right here. Somebody tells me that we got a royal, or that somebody says it's a royal what's the probability that it's going to be a heart? Well, how many royals are there? How many royals are there?
16.
Yeah, there are 16. Okay. And how many of them are hearts?
4.
4. Which is a fourth, which is exactly the same as the probability of getting a heart. So the odds did not change, right? So either of these tell us that the probability or that the events R and H are actually independent of one another, okay?
What would it be called if one of
What's
the,
that?
What would it be called if one direction was independent, but then the other direction it was like dependent?
That can't happen. That can't happen. Remember, I showed you in the video that like if one of these things happens, guess what? They all happen. So if R given H is the probability of R, then it's automatic that the other one will happen also. Does that make sense?
So we didn't need to do the second one to prove that it was independent. The first one was good enough.
Say again. Say again.
We didn't need to do the second line to prove that it was independent.
No, right. I was just showing you that the computation worked out for sure. But when I did the lecture, in the lecture, I showed you that all three, like there are 3 different things. There are actually 3 different things that that are automatically going to be true when you have independence. What were they? It was like the probability of A given B will be the probability of A. And if this happens, then for sure the probability of B given A, what will that be?
Just the probability of B.
Probability of B. And also another way to say it, what was, can anyone recall, what's the other way that you can say it? The probability of
A union B, or not union,
intersected with B.
intersected with B is equal to the product of their probabilities.
Yeah, the product of their probabilities. All 3 of these are equivalent ways of saying the same thing. If one happens, they all happen. Does that make sense? Hopefully. Okay. This right here this is like my go-to example, the heart royal example. Okay. If someone, so I mentioned at some point that, you know, I oftentimes will get prob and stats books in the mail. Hang on a second. I'll get prob and stats books. Oops. I'll get prob and stats books that they want me to evaluate for potential use in the classroom. And what am I doing here? Sorry, guys. Can you see me? Is it fine? Okay. They'll give me prob and stats books to evaluate for potential use in the classroom. And I go to the independence section immediately. And if they ever say that independence means that 2 events don't affect each other, that thing goes straight in the garbage, because that is not what independence means. Independence means that the occurrence of the one does not change the probability of the occurrence of the other. Does that make sense? That's what independence means. Okay. If 2 events do not affect each other, they will be independent. But just because they're independent does not mean that they can't influence each other. They definitely can influence each other. So that's an important distinction. What happens is basically, if you're given the one event, if you zoom in on that event as the new sample space, the other event eats up the same proportion of that new sample space that it did of the whole original sample space. Does that make sense? So when you zoom in to that event that you're conditioning on, the given event, the proportion that the other event eats up of that is the same as it ate up of the entire sample space. That's what independence means. Okay, so yeah. All right, that is a great question. Great question. Okay. Who else? Anybody else? Other questions? By the way, I will continue to post these little sessions, Q&A sessions during class. I'll post. I'm posting them all on Canvas. Okay, so I'm automatically recording these, and I will post them all, just in case you want some supplementary stuff to look through. Okay. What else? Anything else? Yeah, great question, Ryan. So can someone explain to me, so you told me I could pin it, but I can also unpin it. Is that right? So that it will then pop up whoever the talker is or something?
Yeah, you just right click it again.
Yeah. If I pin it, does it pin it for everyone or just for me?
Just
Just
you.
for you.
Okay. Do you, like if you're watching a video that's on Canvas, are you able to do that? Like, can you pin, like if there's a small, can you zoom in on that though?
No, I don't think so.
You don't think so? Okay. Okay. All right.
It would be nice if you could, when you're recording the lectures, if you could move the PowerPoint over to like the left side so that you could make your video bigger so we can see the whiteboard better. But I don't know how you could do that.
Move it to the left.
There's a lot of black space on the left side that's just wasted. If we could shift the PowerPoint to the left so that we got rid of the black space and then the video could be bigger, that would be better.
Oh, I see. Well, I mean, I could do that just by not putting it in full screen mode. I could just move it over. Does that make sense? Just have it be like an open PDF file. Yeah.
Do you have the answers to the examples from the Monday lecture on the conditioned probability stuff?
Oh, the answer, well, no, not in front of me. I guess I was just sort of relying on just the process is more what I'm concerned about. So, I don't have the answers with me, no. But I mean, did the process at least make sense, Summer?
Yeah.
Okay. So you should be able to get those various probabilities. I don't know that
I just wanted to double check answers and stuff.
Oh, okay. Yeah. Does somebody have those written down? I don't have them written down in front of me. Like the probability of a credit card. Does anybody have that? Was that like what you were talking about, Summer?
Yeah.
I mean,
Yeah.
I go
I
ahead.
think I have some of them.
Oh, okay.
So which problem first? Did you get the box ones?
What?
Did you get the box ones, or are you looking for just the credit card one?
Just the last two.
The last two.
So the credit card and the A3 conditioned on C.
Okay, so A3 conditioned on C and the one before it. All right. Well, the one before it was one where you're calculating the probability of A3 intersected with C. Is that the one?
What?
Or wait, no, did I skip
Yeah,
one?
yeah, yeah, no, that one. Yeah, that one was like C intersected with A1 and then A2 and A3. You had to like add those.
Right. To get the probability of credit card, it was the sum of the probability of C intersected with A1, probability of C intersected with A2, plus the probability of C intersected with A3. And then so you just had to compute each one of those three.
Right.
But I think what Summer's wanting is the actual numbers themselves.
I don't have that one written down, but
It would take a while to do that.
yeah.
I mean, I could compute it and just, put it in an email or something.
Okay.
Yeah. All right. What else? Other questions? Other questions? Well, okay. I'll probably, by tomorrow afternoon or something, I'll try to get the thing posted so you have plenty of time to watch the next one. I'll talk about something called Bayes' theorem, and I will move on to to the statistics textbook a little bit. Hopefully I'll have some time to talk about some things there. So that's kind of the plan for Friday. Again, after this session, I'll finish up this quiz and then I'll post that, and that'll be due on Friday at some point. Probably by like, I don't know, 5 p.m. or something. Okay. All right. Anything else? All right. I'll post this this meeting session somewhere so you can watch that at your leisure as well. But other than that, take care, everyone. See ya.
Thank you.
Yeah.
Thank you.